Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain about another examples of paper 1 higher level prediction question. It's not 100% guaranteed that these questions will appear in the exam. However, you can take this as a mock exam to check whether you are ready for the exam or to find out what kind of topic that you're still struggling with. So if you find this video is helpful, please don't forget to subscribe and let your other friend knows about my channel to support me. And now let's get started. Barium hydroxide and phosphoric acid react according to the following equation. What volume of 0.1 molar phosphoric acid is required to completely neutralize 50 centimeter cube of 0.03 molar barium hydroxide solution? So we've got the we've got the volume of barium hydroxide solution and then the concentration. So we can calculate mole of barium hydroxide, which is C times V. So 0.03 times 0.05, which is 0.0015 mole. And from this, we can actually calculate the mole of phosphoric acid. So that would be 2/3 as a mole ratio times 0.0015, and you will get 0.001 mole. Okay, so now you can find volume of the phosphoric acid, which is N divided by C. 0.001 divided by 0.1, which is 0.01 decimeter cube, or 10 centimeter cube. Even though this needs some calculation, but this can be done by doing manual calculation. It was not that very hard that you need a calculator. Aluminum hydrogen carbonate will decompose to produce aluminum oxide, carbon dioxide gas, and water according to the following equation. If 0.3 mole of aluminum hydrogen carbonate decompose and 10.1 gram of aluminum oxide is collected, what is the percent yield? So we can find out the mole of aluminum oxide. 10.1 divided by 101.96. I know you guys are not allowed to use calculator, but you can do the approximately. That would be 0.1, right? So this would be experimental yield for aluminum oxide. Okay, and for the theoretical yield, because 0.3 moles of aluminum hydrogen carbonate is known, so we can find out the theoretical yield for aluminum oxide, which is 1/2, because the mole ratio here, the coefficient is 1. So 1/2 times 0.3, which is 0.15 mole. So this one for the theoretical yield. To find the percentage yield, that would be 0.1, the experimental yield, divided by theoretical yield, and you will get 67%. Okay, which is not a possible orbital diagram. As you can see here, number of electron, so because it reached to 4s and then 3d10, so it's a full fill. So 4s1 3d10, that would be 18, okay, AR, plus 11, so that would be 29, so it's Cu. And for B, there are electrons that are already removed, so the total here is 24. So it could be either Cu plus or zinc 2 plus. It could be one electron that is has been removed, or two electrons have been removed. Yeah. And for C, 4s1 and then 3d5, this is half fill. So 6 plus 18, which is 24, so CR. And then the fourth one, the 3 orbital is not fill up yet or fulfill, but 4s is filled. I mean, 2 spins are here, 2 electrons are here. This is wrong. We need to follow these rules. It should be half filled or full filled. So this electron actually should be right here first. So that would be 4s1 and then 3d10. So it's not possible. Orbital diagram would be D. Given below is the mass spectrum of the stable isotopes of rubidium. What is the relative atomic mass of rubidium? As you can see here is 77%, maybe around 77, and this one maybe around 23. So Rb 85 is the most abundant isotope. Therefore, the relative atomic mass should be closer to 85, not 87 is more abundant here. So the one that is close to the 85, it's 85.5. The successive ionization energies for an unknown element are shown in the graph below. Which of the following statements regarding these elements are correct? Removal of the fourth electron is from a different energy level than the first 3 electron. You can see here there is high jump. It means to remove the fourth electron, it is from different energy level. So this one is correct. This element belongs in group 13 on the periodic table. So these 3 are closer. It means it has 3 for valence electron. So if valence electron is 3, so it comes from group 13. So this one is correct as well. The effective nuclear charge is decreasing with the removal of successive electrons. It shouldn't be decreased, it should be increased, because after removing the electron, the atomic radius will be smaller, so it has a greater attraction. So the nuclear charge should increase with the removal of successive electron. Therefore, the answer will be B. The wavelength for a particular electron transition in an element is measured to be 600 nanometer. Which calculation below represents the correct calculation for the determination of the energy of a mole of electrons undergoing this transition in 1 kilojoule per mole? As we know, the formula C lambda times frequency, and then E would be Planck constant times speed of light divided by lambda or wavelength. So H, Planck constant, is 6.63 times 10 to the power negative 34 joule, and then speed of light is 3 times 10 to the power 8 meter per second, and wavelength is 600 nanometer. We can convert it by 6 times 10 to the power negative 7 meter. So the value must be multiplied by Avogadro's number, which is 6.02 times 10 to the power 23, because it is to determine the energy from 1 mole electrons, okay? And as it is should be in kilojoule per mole, so we need to divide it by 1000. So this one is no, this one is no. So either A or D, but we need to multiply with the Avogadro's number. So both of them also multiply by the Avogadro's number, but the only difference is this one. So this one is 600, but this one is 6 times 10 to the power negative 7. This is the answer because we have speed of light, which is meter per second, so we need to convert the wavelength to be meter. So the answer is D. Number 7, which of the following statements are true? A neutral atom of a noble gas contains a complete p subshells. Correct, because when we look at to the periodic table, this will be block S, this will be block D, and this will be block P. So noble gases will be here. For example, 2s1 to s2, 2p1, 2p2, 2p3, 2p4, 2p5, and 2p6. All noble gases has 2p6, 3p6, 4p6. So a neutral atom of a noble gas contains a complete p subshells. Period 3 contains the most nonmetals. Period 3, Al, okay, is still considered as a metal, and Si is a metalloid. So contains the most nonmetals is incorrect. Some elements in group 14 are metalloids. Group 14 are metalloid. Si and germanium, Ge, are metalloids. Correct. So the answer will be B. Which complex ion below would be colorless? Fe2 plus would be Ar 3d6. It has D subshell. Sc3 plus, okay, that would be same with Ar. Sc has a number of electron 21, so 3 plus lose 3 electron becomes 18, so the same with Ar. The answer is B because it has no D subshell. Let's check for C. Cu2 plus, that would be Ar 3d9. CO2 plus, that would be 3d7. So this one is colored. So Sc has no color because it has no D orbital. Which of the below statements about the halogen in group 7 is or are correct? The electron affinity for bromine is the energy required to add 1 mole of electrons to gaseous bromine molecules to form bromide ions. It is correct, but it shouldn't be molecule. It should be gaseous bromine atoms. The electron affinity for chlorine is smaller in magnitude than that of fluorine. Cl, as Cl size is bigger than fluorine because it's down, so Cl down of F. So as you go down a group, the electron affinity is smaller than F because the atomic radius is bigger. So of chlorine is not smaller. Sorry. So for electron affinity for chlorine is smaller because the atomic radius getting bigger. So it's the attraction is smaller, so it's easier to add the electron compared to fluorine because fluorine has smaller atomic radius, so it's more difficult to add the electron, so it has bigger in magnitude for the electron affinity. Potassium reacts more vigorously with chlorine than with bromine. It is correct as well because chlorine is more reactive than bromine. So when it is reacted with non-metal that is more reactive, of course the reaction is more vigorously compared to one that is less reactive. Therefore the answer is B. The Xe atom in XeF2 has 3 non-bonding pairs. So this would be like this. Okay. Of valence electron and shares 2 bonding pairs of electron with F atoms. Which of the following statements are true? XeF2 has the band molecular geometry. It is wrong. It has 1, 2, 3, 4, 5 domain. So it's the molecular geometry is trigonal bipyramidal. The Xe atom has an expanded octet of valence electron because the bonds and a lone pair has a total of 10 valence electron. Therefore, Xe has expanded octet. The formal charge of the Xe atom is 0. Let's calculate the formal charge of Xe. So valence electron is 8 minus half with number of bonding electron, which is 4, and minus non-bonding electron, which is 6, so 0. Correct. So the answer is 2 and 3 only. The Lewis structure of ammonia is shown. How is the electron domain geometry of ammonia related to the hybridization of the N atom? So it has 4 domain, therefore is sp3. And if it's 4 domain, the electron domain geometry will be tetrahedral. 2 Lewis structures of gases beryllium difluoride are shown. Which of the following statements is true? Okay, let's calculate the formal charge. For this Be would be valence electron minus half bonding electron, which is 8, minus non-bonding electron, there is no, so that would be -2. For this Be, formal charge will be 2 minus half times 4 bonding electron, minus there is no non-bonding electron, so that would be 0. So structure B is preferred because B and F have 0 formal charge. Let's calculate for F then. F would be, F comes from group 7 minus half times only 2, and it has 6 non-bonding, which is, so this one 7, so 6, so 7, sorry, wait, so this one will be 1 and then minus 6. Let me just repeat it again. 7 minus half times 2 minus 6. Okay, so 6 minus 6, so that would be 0. So D is correct. A neutral atom of element X has the electron configuration shown. Element X reacts with oxygen gas O2 to produce an oxide material. What type of bonding occurs in this oxide material? It has, it is period 3 because it has 3 shells, and it has valence electron, which is 4, and its number of electron is 2, 8, 4, so 14, definitely Si, so it's silicon. Okay, when silicon reacts with oxygen, it will be silicon oxide. Silicon oxide, it has a giant covalent structure. Which of the below gives substance in the correct order of increasing boiling point? So the key here is the greater molecular mass, it will have a greater London dispersion force, because Cl2Br2 has London dispersion force, and IBr as well, due to the electronegativity difference. Okay, because they are quite close. IBr and Cl, they comes from the same group, so all of them has have London dispersion forces. So to differ the one that has highest or strongest dispersion force, it is the one that has higher molecular mass. So ICl, first let's compare Br2 and Cl2. Br2 has higher molecular mass. Okay, so we compare between ICl and IBr. ICl has a slightly higher molecular mass than IBr, so IBr has the highest molecular mass among the substance. Therefore, the answer will be B. Some of the electrons in molecule A are delocalized, giving rise to resonance structures. Molecule A features a bond angle, which is 119. Which of the following is possible structural formula of molecule A? C has no resonance because it has no double bond. And then D, it's impossible for C becomes double bond with H because H only can form a single bond. So now between A and B. For B, it has 3 domain. Okay, 3 domain, and there is no pair of electron that would give a repulsion. So this will be only 120 degrees. The same with this will be 120 degrees, but it has one pair of electron here that will cause a repulsion, so the bond angle will be slightly smaller. So it's not 120 degrees, but smaller than 120 degrees. That's why the answer, it's A. Which expression represent the entropy change in Joule K per mole for the following reaction? So delta S will be delta S product minus delta S reactant, which is plus 214 plus 38 minus 93. The answer is C. A 4.3 gram sample of butane is combusted and the release energy is used to heat 750 gram of water. The temperature of the water increased by 68. What is the enthalpy of combustion of butane in kilojoule per mole? So to calculate delta H, that would be heat capacity divided by mole. So because the temperature increases, that would be negative. So MC delta T divided by, we've got mass right here, and then molecular mass right here. So N divided by MR, and this should be in kilojoule. So times 1000, okay? Because this should be divided by 1000. So negative MC delta T times MR, because it will go up here, divided by M times 1000, because any number should be divided by 1000 because we need to make it into kilojoule. So the answer will be A. And we don't need to add 273 anymore, because when the temperature that already calculate, the difference in temperature is already in Celsius, we don't need to add with the Kelvin, because you will get the same number. So unless if it's the two temperatures are known, but if the difference in temperature is already known in Celsius, you don't need to add into Kelvin, or you don't. What is the correct order of decreasing lattice enthalpy? Lattice enthalpy depends on the charge and the size of the atom. So we've got Mg here, Mg, and oxygen. Mg has charge 2 plus and oxygen 2 minus. Of course, this 2 has highest charge. And we've got Na also with Li. Okay, to compare these two, we need to look at to the size. Okay, so Na plus has a higher ionic radius compared to Li, because Na is down than Li. Therefore, the answer will be D. MgO has higher charge, and then Mg and F, because still has Mg, and then we move to Li, and then we move to Na. A rate law of a reaction is determined to be rate K times concentration of A and then B squared. What are the units for the rate constant? Rate constant will be rate divided by concentration of A and then B squared. So rate unit would be mole, decimeter to the power -3, and second to the power -1. So we've got mole, decimeter to the power -3 to the power 3, because here is 1 and here is 2. So we can remove this 1 and becomes now 2. So S to the power -1, that would be mole squared decimeter negative to the power -6. So now we bring it up, mole to the power -2, decimeter to the power 6, and S to the power -1. So the answer is B. Which graph below represent a second order reaction? The answer is C, because this between the concentration and time. The first one is zero order. The second one, this should be rate of reaction and concentration. And then the D graph is the first order. The rate constants for a reaction are plotted in a graph of ln k versus 1 over t. So this will be slope, which is negative EA divided by R. And y2 minus y1, x2 minus x1, yeah? So we can change it into A minus B, okay, divided by C, okay? And to find the EA, of course, this one times R. So A minus B divided by C times R, which is D. Identify the intermediate and catalyst respectively for the following proposed reaction mechanism. It has step 1 and then step 2. Which one the intermediate and catalyst? It's ClO and Cl. Why? Because look, we can actually eliminate them. So that would be 2O3 gas produce 3O2 gas. Okay, ClO is an intermediate because it is produced in one step and consumed in a subsequent step. And for Cl is a catalyst because it is present at the beginning and at the end of the reaction, but it doesn't appear in the overall equation. Which of the following statements about a system at equilibrium are correct? For the first one, at equilibrium, neither reactants nor products are favored, resulting maximum entropy and minimum Gibbs-free energy. Correct? The Gibbs-free energy is at maximum at equilibrium? No, because it's minimum Gibbs-free energy at the equilibrium. The Gibbs-free energy change is 0 at equilibrium. That is correct. Delta G equal to 0 at equilibrium. So the answer is B. Consider the following reaction. At time t, the quotient is equal to 4.2 times 10 to the power negative 3. As the reaction proceeds, the pressure inside the reaction vessels increases. What can be deduced about the value of Kc? When the pressure increases, it will shift to number of fewer gas molecule. Okay, so here we've got how many? 4, and here we've got 2. So it will shift to the left. So because it shifts to left, Kc will become smaller than Q. The equilibrium constant for the flowing reaction is 0.21 at 100 degrees Celsius. Which expression represents the Gibbs-free energy change at this temperature in kilojoule per mole? So delta G is negative RT ln K. So negative 8.31 J per K mole times 100 times plus 273. So that will be Kelvin times ln 0.21. And it should be in kilojoule, so we need to divide it by 1000. The reversible reaction of NaClO with CH3COOH is shown below. Why does the addition of CH3COO and A affect the position of equilibrium? You know, when you add CH3COO and A, it will provide CH3COO minus ion into the solution, right? and this CH3COO minus will react with H plus from HClO, because this is the equilibrium, so there will be partially dissociate here, partially dissociate here, partially dissociate here. So this CH3COO minus will react with H plus from HClO. Therefore, CH3COONA, it will be a conjugate base, and this one conjugate acid. This one would be acid, this is weak acid, and this one is base. So the answer will be D. In a reaction between an excess of potassium carbonate and 2 mole of hydrochloric acid, how much water is produced in moles? Potassium carbonate, K plus CO3 2 minus, so crisscross K2 CO3 and HCl. So K2CO3 plus HCl. Okay, so that would be H plus and Cl minus, CO3 2 minus, and then K plus. So this will be with KCl, and this would be CO2 and H2O. Because why? Because as long as you have CO3, it will always produce CO2 and H2O. That's the key. So let's balance them. 2 and then 2. What if Na2CO3? Still, it will produce CO2, H2O. As long as you have CO3 there, it will produce CO2 and H2O. And the salt. The pKb of NH3 is 4.75 at 298 Kelvin. What is the Ka? So pKa plus pKb is 14, right? So pKa would be 14 minus 4.75, which is 9.25. So Ka would be 10 to the power pKa, which is 10 to the power 9.25. Number 29. Which of the following is both a Bronsted-Lowry acid, which is Dunor H+, and Lewis acid, which is electron pair acceptor? Okay, H2O has H+, but it cannot donate an electron pair. H2O, when it donates H+, it will leave OH minus. So this only Bronsted-Lowry acid, but not Lewis acid. H3O plus is electron deficient, so it's able to accept a pair of electron, and it has an extra proton, so it will act as both Bronsted-Lowry acid and Lewis acid. The same goes to NH4 plus. It needs more electron because it's plus, and then it has H plus extra, so it acts as both Bronsted-Lowry acid and Lewis acid. So the answer is C. What is the sum of the coefficients when the following redox equation is balanced? So we've got Br minus and Br2. So this will be 2. Let me just make it a bit smaller so we've got more room. So Br minus becomes Br2. So that would be 2 right here. And we need to add 2 electrons right here. So it's balanced now. And we've got another half equation, which is H2O. So O2 here. So we just need to add 2. And now here is, it has 4H2. I mean 4H plus, and the charge is not balanced, so we need to add 4 electron here. So now it's balanced, but the electrons are not balanced. Therefore, this will times 2 and then times 1. So 4 Br minus becomes 2 Br2. I don't need to write the electron anymore, and this one 4H plus O2 becomes 2H2O. Okay, so this would be 1, this would be 4, this would be 4, this would be 2, and this would be 2. So the total will be 5, 9, 11, and 13. In the reaction below, which of the statements below is correct if the reaction is assumed to be spontaneous? So the reaction below, it's spontaneous reaction, which is voltaic cell. Let's check which one is the oxidation and reduction. So this one -6, and that would be +5 because equal to -1. This one is +1, this one is 0, this one is +2, this one is -2, so +2, and this one -2, +2, and then +1. Okay, in the voltaic cell, gas would appear at the cathode. This one, reduction. Okay, because +5 change to +2. And then this one will be oxidation. In the voltaic cell, gas would appear at the cathode. So 2NO3 minus will produce 2NO gas. Okay, so it's true because at the cathode will experience reduction. So at the cathode, gas would appear, which is NO gas. In an electrolytic cell, copper metal would appear at the cathode. This is the spontaneous, which is the voltaic cell, but if it's electrolytic cell, the power source drives reverse as it is now non-spontaneous. Therefore, the one that is being reduced or reduction change to be oxidation, and this one will change to be reduction. So now Cu experience reduction in an electrolytic cell. So the reaction will be Cu2 plus 2 electron produce Cu at the cathode because it is a reduction. So copper metal will appear at the cathode, correct. Hydrogen is reduced, no, as you can see, +1, +1. So there is no reduction or oxidation for hydrogen. Therefore, the answer is C. The permanganate ion MnO4- is an excellent oxidizing agent. Oxidizing agent cause a species that is reduced and cause oxidation. So the one that has oxidation is D. Negative +2, -2, so -1. This is 0. -2 +2 and +1. +2. -1, -2, -1. Okay, so it's oxidation. So reduction. -1 to -2, reduction. This one -1 and this one 0, reduction as well. This one +3 to +2, reduction as well. That's why the answer is D. An electrolytic cell contains molten magnesium chloride. Which of the following statements is correct using the standard cell potential given below? So we've got Mg and then Cl. For the electrolytic cell, so it's panic, positive will be anode and negative will be cathode. It will experience oxidation always at the anode and then reduction at the cathode. So we've got Mg2+ is positive ion will go towards negative electrode, and then Br- as a negative ion will move towards the positive electrode. So the answer will be A. Magnesium is reduced. Okay, and magnesium metal will appear at the negative cathode. 2-chlorobutane undergoes an SN2 reaction with sodium hydroxide. What is the structure of the transition state in this reaction? Okay, there is no Cl because when it is transition state, it will contain both the leaving group, which is 2-chlorobutane, which is chloro, Cl, and then OH minus. So it will contain both OH minus and then Cl as a transition state. For A, there is no Cl, and then for C, there is no OH, and then for B, and then D, it both contain OH and Cl. But the difference here, the one that has dashed line is only OH but not Cl. It should be both, okay? Because this will show the molecule is being added and then we leave simultaneously or continuously. So the answer will be D. Compound A is non-superimposable mirror image of compound B. For which of the following properties does compound A display the same values as compound B? Non-superimposable mirror image, it means this one is enantiomers. Enantiomers, unlike other isomers, they share all these properties, even density. So it will have the same melting point, solubility in water, pKa, even density. So the answer will be D. The condensed structural formula of an organic compound is shown. What is the IUPAC name for this compound? We've got CN as C number 1, C number 2, C number 3, and then 4. So CN is the nitrile, and then we've got alkyl at C number 3. Therefore, the answer will be D. An organic compound X belongs to homologous series with the general molecular formula CnH2n plus 2O. This is a general formula of alcohol, and it's not oxidized by potassium dichromate. It means it is a tertiary alcohol. As you guys know, if it's primary alcohol, oxidized becomes aldehyde, and then further oxidation will produce carboxylic acid. And for the secondary alcohol, when it is oxidized, will produce ketone. But for the tertiary alcohol, will not undergo oxidation. So we need to find which one the tertiary alcohol from these A, B, C, D options. So the first one, that would be CH3. The white one is H. The gray one is C. This should be O, and then this one of course is H. So CH3, CH2, and then we've got CH with OH, and then we've got CH3 here. So this is secondary alcohol. And for C, CH3, and then there's C double bond O, and then CH3 ketone. And then for D, CH double bond O, and then CH, and it got CH3, and it got CH3 here. So this is aldehyde. And then for the B, so that would be CH3, and here C, and then here CH3, and then this CH3, and then OH. So this is the answer, is the tertiary alcohol. Which of the following is the rate determining step RDS of an SN1 reaction? For the fourth option here, okay, so first SN1, it has a unimolecular rate producing carbocation intermediate. So the first one, it should produce Cl1, so this is not the case. But let's see the key here. The rate of SN1 reaction is not affected by changing the nucleophile, because the nucleophile attacks only after the rate determining step. Nucleophile is only involved in the fast step after the rate determining step. So it means for the rate determining step, as the question here, of SN1 reaction shouldn't have any nucleophile is involved. So the answer is C, because here except doesn't produce Cl minus, but it has OH minus. It has OH minus, and this one I'm not really sure what kind of error is this, so that's why the answer is C. The structural formula of ethylbenzene is shown. One of the sinyl in the HNMR spectrum of ethylbenzene is quartet. What are the integrals of the 4 peaks in the quartet sinyl expressed as a ratio? So you know the formula: 1, 1, 1, 1, 2, 1, and 1, 3, 3, 1. So this one will be singlet, this one will be doublet, and then this one will be triplet, the splitting pattern formula, and then this one will be quartet. So for the quartet will be 1, 3, 3, 1. Eugenol, the main fragrance compound in cloves, has the following structural formula. The mass spectrum of eugenol is shown. The molecular ion produced a peak at value of 164. Okay, so this one at 164. Which fragments are lost from eugenol to produce peaks value at 137 and 149? So 164 minus 137 would be 27, and minus 149 will be 15. If it's 15, definitely CH3. So between C and D. If it's 27, let's check. We've got option C2H3 and OCH3. C2H3 is 27, OCH3 is 15. So it is definitely C2H3. So the answer is C. Alright, so that's all for the explanation. Another example of prediction question for the for your exam preparation or revision. Again, as I mentioned, these questions are not guaranteed would be appear in the exam, but it is very good for you as a mock exam to check your understanding or your the readiness for you for the exam, or to check what kind of topic that you are still struggling with, so you can go back and then do some revision on that topic. And if you find this video is helpful, please don't forget to subscribe and let the other friend knows about my channel to support me. Thank you for watching, and bye.